For centuries, humanity has gazed into the night sky and asked, where did we come from? What if everything you thought you knew about the beginning of the universe was just the tip of the cosmic iceberg? Today, a revolution in astrophysics reveals a deeper, more mysterious history, one hinting that the true origin of our universe lies not at the Big Bang, but before it. By exploring newly uncovered cosmic evidence and the frontiers of modern science, this documentary presents a journey that only the boldest minds have dared to take. With access to the latest discoveries from leading observatories, the James Webb Space Telescope, and Nobel-caliber cosmological evidence, this story unites secrets decoded from cosmic microwave background radiation, the structure of space-time, and clues of an epoch before the Big Bang itself. Prepare for your understanding to be transformed. What happened before the beginning? And what truths, hidden in the fabric of the cosmos, will change how we see ourselves forever? The answers revealed now will challenge all you know. Number 1. The classic beginning, Big Bang, and beyond. Dramatic pause, with soft, cosmic background music. Picture, if you will, the ultimate beginning. 13.8 billion years ago, there was nothing. No space, no time, no matter as we know it. Then, in an instant that defied all comprehension, everything that would ever exist erupted from a single point, a mathematical impossibility called a singularity. This was the Big Bang, not an explosion in space, but the explosive birth of space itself. In that first fraction of a second, the universe expanded faster than light could travel, stretching from smaller than an atom to the size of a grapefruit in less time than it takes light to cross a proton. The narrator's voice becomes more intimate, as if sharing a cosmic secret. At 1 second after this cosmic dawn, the universe was a seething cauldron of fundamental particles, quarks dancing with electrons, photons ricocheting in every direction, neutrinos ghosting through the chaos. The temperature? An incomprehensible 10 billion degrees Celsius. Nothing we know today could have survived even a microsecond in this primordial furnace. But the universe had a plan written in the laws of physics themselves. Music builds with anticipation. 3 minutes after the beginning, something remarkable happened. The cosmic temperature had dropped enough, though still a billion degrees, for protons and neutrons to stick together. In those crucial moments, the universe forged its first atomic nuclei: hydrogen, helium, and traces of lithium. This was Big Bang nucleosynthesis, the universe's first attempt at chemistry. For the next 380,000 years, the cosmos remained a glowing fog. Photons, particles of light, could barely travel without colliding with free electrons that permeated all of space. The universe was as opaque as a thick London fog, yet blazing hotter than the surface of the Sunday. The narrator's tone shifts, becoming almost reverent. Then came the moment cosmologists call recombination, though it was really the first time these particles ever combined. The universe had cooled to a mere 3,000 degrees. Electrons finally settled into orbit around nuclei, forming the first neutral atoms. Suddenly, the fog lifted. Light could travel freely for the first time. That ancient light, stretched and cooled by billions of years of cosmic expansion, still bathes us today as the cosmic microwave background radiation. It's the universe's baby picture, and two Bell Labs scientists, Arno Penzias and Robert Wilson, accidentally discovered it in 1964 while trying to remove what they thought was just annoying static from their radio antenna. Music becomes mysterious, almost haunting. But discovering that ancient light revealed something extraordinary and troubling. After recombination, the universe entered what cosmologists now call the cosmic dark ages. For nearly 200 million years, no stars existed, no galaxies, no light sources whatsoever. The universe was filled with invisible hydrogen atoms, drifting in the darkness, waiting. Gravity was the only sculptor, slowly pulling matter together into ever denser clumps. Here and there, in the deepest gravitational wells, something was stirring. Then, Somewhere between 200 and 400 million years after the Big Bang, the first stars ignited. These weren't gentle, sun-like stars. They were monsters 30 to 300 times more massive than our sun, millions of times brighter, burning with nuclear fury that would make our sun seem like a flickering candle. The narrator's voice rises with excitement. These stellar titans lived fast and died young, exploding as supernovae after just a few million years. But in their brief, violent lives, they accomplished something miraculous. They began cooking the first heavy elements in their cores: carbon, oxygen, nitrogen. The building blocks of planets and life itself were born in the nuclear furnaces of these first stars. Music becomes triumphant, celebratory. For most of human history, we knew none of this. The universe seemed eternal and unchanging. Then came a quiet revelation that would shatter our cosmic complacency. In 1924, Edwin Hubble peered through the 100-inch telescope atop Mount Wilson and spotted something extraordinary in the Andromeda Nebula, a single variable star that proved this fuzzy patch of light lay far beyond our own Milky Way. With that discovery, the known universe expanded overnight from one galaxy to billions. But Hubble wasn't finished rewriting the cosmos. 5 years later, working with measurements from astronomer Vesto Slipher, he made an even more startling discovery. The universe wasn't just vast, it was expanding. Every distant galaxy was racing away from us, and the farther away it was, the faster it retreated. The narrator pauses for dramatic effect. Though few knew it at the time, a Belgian priest and physicist named Georges Lemaitre had actually beaten Hubble to this conclusion by 2 years. Lemaitre realized that if you could run this cosmic expansion backward, like rewinding a movie, you'd eventually reach a moment when everything was compressed into what he called a primeval atom. He had discovered the Big Bang before it even had that name. Music fades to an unsettling, questioning tone. And so we arrive at our modern creation story. 13. 8 billion years ago, the universe burst into existence, expanded, cooled, and eventually gave birth to stars, galaxies, planets, and us. But this well-worn tale, elegant as it is, leaves us with haunting questions that gnaw at the foundations of everything we think we know. Why did the Big Bang happen? What caused it? And perhaps most unsettling of all, what came before it? What set the cosmic stage for this ultimate beginning? Silence, then a whisper. These questions would soon lead us to discoveries even more mind-bending than the Big Bang itself. Discoveries that suggest our universe's true story had barely begun to be told. Music swells ominously as we prepare for the next segment. Number 2. Cracks in the cosmic egg. Mysteries the Big Bang can't explain as telescopes map the heavens. Astronomers began to realize a quietly unsettling truth. The stars, planets, and galaxies, everything we can see, represent just a tiny fraction of the cosmos. A vast, invisible realm shapes our universe, its presence known only through gravitational whispers and the strange behavior of galaxies. Together, these unseen forces, dark matter and dark energy, compose nearly 95% of everything in existence. Imagine a universe woven from invisible threads. Dark matter, making up about 27% of the cosmos, neither emits nor absorbs light, yet reveals its power through gravity. First noticed in the 1,930 seconds, the galaxies within a cluster were moving too fast to be explained by visible mass alone. Later, Vera Rubin's studies in the 1,970 seconds revealed that stars and spiral galaxies rotated at unexpected speeds. It was as though galactic disks were surrounded by halos of hidden material. Today, we picture the universe's structure as a cosmic web, where dark matter creates the deep wells into which galaxies and clusters fall. But what is dark matter? Despite decades of research, scientists still don't know. The best guess, some unknown type of fundamental particle, possibly formed soon after the Big Bang, waiting to be discovered at the frontiers of physics. If dark matter is the glue Dark energy is the cosmic engine making up about 68% of the universe. In 1998, astronomers measured the light from distant supernovae and found the universe's expansion was speeding up, not slowing down as expected. Some unseen force is pushing galaxies apart, stretching the cosmic fabric itself. This repulsive force, now called dark energy, is tied to the very vacuum of space, an enigma that acts across all time and space, invisible yet overwhelming. Its identity? Still unknown. It's as if the universe itself is trying to accelerate away from comprehension, leaving scientists racing after a shadow. The deeper scientists looked, the stranger the story became. According to physics, every particle of matter should have a twin antimatter with nearly identical mass but opposite charge. Particle colliders create matter and antimatter in equal measure, but when they meet, they annihilate in a flash of pure energy. So, why do we exist at all? The Big Bang should have forged equal amounts of each, destroying all hope of planets, stars, or life. Yet, for reasons unknown, matter barely edged out antimatter by perhaps 1 part in 10 billion, enough to survive and build the universe we know. How this miraculous imbalance happened remains one of cosmology's most profound unsolved mysteries. After the Big Bang, a sea of light filled space, becoming today's cosmic microwave background, CMB. A faint afterglow, uniform across the entire sky. Yet, this remarkable uniformity presents its own puzzle. How could regions so far apart, separated by billions of light years, with no time to communicate, share exactly the same temperature? The CMB's perfect smoothness defies explanations, leaving scientists searching for answers in theories of inflation, quantum fluctuations, and physics beyond the standard model. These mysteries, dark matter, dark energy, the matter-antimatter imbalance, and the cosmic microwave background whisper that the Big Bang is not the whole story. Each unanswered question dials up the cosmic suspense, inviting us ever deeper into the fabric of reality and lighting the way for the next generation of cosmic explorers.